They actually distributed both first things first. Love it, okay? That is what I would have done as well, okay? So you're going to take this -2, you're going to distribute it. You're going to take this -3, you're going to distribute it. What's my new equation after I distribute? Did anyone get it? Daniel, what'd you get?
-6x plus 4.8 equals -9x plus 7.2.
Bingo, bango. That is 100% right, okay? From here, what would we do with this equation? Someone else. Storm? You would add 6x. Wait, what did you say? Thank you. Subtract 4.8. That is absolutely right. So we're going to get -6x equals -9x plus what? Things like what? 2.4? 2.4. Then what? Javonsky? Love it. What do you get, Javonsky?
3x equals 2.4.
Good. From here, what do we do? Daniel? Divide by 3. Okay, now let's walk through that division, okay? 2.4 divided by 3, right? How many times can 3 go into 2? 0. How many times, but before you move on, bring that decimal up. Now treat the 2.4 as 24. How many times can 3 go into 24? 8. Evenly? Sure can. It's 224. We get a remainder of 0. Cool beans? So now my answer is 0.8. We Gucci? All right. So, and then we would shade to the right. Do you guys remember that? Yeah. If x was bigger than 6, okay? Now, what we're going to be talking about today is what do we do when we have x and y and an inequality, okay? X and y and an inequality, okay? So the answer is we're going to graph them, okay? And it's going to be a region of the graph. So it's not just like a spot on the number line. It's not just like a set of numbers. It's going to be a whole region, a whole set of coordinates, okay? So the first thing that we're going to do is we're going to be able to test whether something is a solution or not, okay? Now, do you guys remember when we did this for equations? We would plug in x and y and see if it was equal to each other on both sides. Now we're going to plug in x and y and see if it's the inequality holds on both sides, okay? So take a look at the two-step process. You plug in x and y, and then if the inequality is true, it's going to be a solution. If the inequality is false, guess what? It's not a solution, okay? So these first few should be fairly simple. Let's try them out. So the point that I'm testing is -1, 9, and the inequality is 2x plus y is less than -3. What do I plug in for x? -1. So we're going to go 2 times -1 plus, what do I plug in for y? 9 should be less than -3. 2 times -1 gives me? And then you add 9 to that. What do you get? So we have 7 is less than -3. Ask yourself, is this a true or a false statement? False. So guess what? Is -1, 9 a solution? No. Not a solution. Notice how I'm saying it's not a solution, and I'm not saying it's not the solution, okay? Because there's going to be a bunch of different solutions, actually infinitely many, for these inequalities, okay? So it's not a solution. Cool beans? Yes. Let's check out B. Okay? In B, we're going to plug in -2 for y and 2 for x. So once we plug it in, it's going to be 2 minus 3 times -2 is greater than or equal to 8. You guys with me? What's -3 times -2? Gabby? 6. So plus 6. Is 8 bigger than or equal to 8? Yes. So this one is a solution, okay? We're going to write 2 -2 is a solution. Is it the solution? No, because there can be more than one, okay? These are inequalities. Are we Gucci so far? Okay. C. X plus y is greater than 0, -2 and 2. Preston. When Kristen comes back, okay? So we're going to plug it in. We're going to get -2 plus 2 should be greater than 0. We get 0 is greater than 0. No. Why not? It's not equal to, okay? 0 is equal to 0, but our inequality does not include equal. You guys... Oh, I'm sorry. Thank you. That should be an X, okay? So this is not a solution. These aren't too bad, right? We're going to do D, and then if you guys want to jump ahead, do E and F, okay? We've got 4x minus y is greater than or equal to 5. We plug in 0, we plug in 0. We're going to get 4 times 0 minus 0 is greater than or equal to 5. This is 0 is greater than or equal to 5. Is that true? Nope, it's false. So we say not a solution. Do E and F. If you think you got them, raise your hand. Okay. Mm-hmm. Good. So negative 20 plus 2 is less than or equal to negative 1. Excellent. Now, this is a little bit confusing for a lot. Storm, that was excellent. Okay, very good job. Guys, which one's smaller? Negative 18 or negative 1? Negative 18, okay? It's hard to think about because 18 is a bigger number, right? But technically, it's further away from 0. Well, in the left direction, right? It's further negative, okay? So this is a true statement. So it is a solution, okay? Our solution, one of our solutions is negative 4 comma negative 1, okay? For the second one, solution or not a solution? Gabby?
It is a solution.
It is also a solution. Walk me through it, Gabby.
Okay, so you put negative 2, and then for x you put 5. So negative 2 times 5 minus 3 times negative 7 is less than 15.
Good.
That gives you negative 10 plus 21 is less than 15.
Mm-hmm.
And that's 11 is less than 15, which is a solution.
Excellent. 11 is definitely less than 15. This is a solution. Okay? Are we Gucci so far? Okay? First part of this lesson is super important. Okay? So make sure you remember what we just did. Okay? All right. The second part of the lesson involves graphing these bad boys. Okay? So, graphing linear inequalities into variables. Okay? And there's a 3-step process. Okay? Step number 1 is called the boundary line. Okay? We're going to graph the boundary line of the inequality, okay? When we use the dashed line, for example, less than or greater than, we are going to, that's a dashed line, okay? So put a dashed line above that. And when you're using less than or equal to or greater than or equal to, that's going to be a solid line. So put a solid line above that portion, okay? Now, take a look back up at our image, okay? In this graph, this is the graph of y is less than 2x, okay? It's exactly, this boundary line is exactly y equals 2x, okay? Circle that part. The boundary line is exactly the same inequality, but instead of less than, what are they putting? Equal to, okay? That's going to create your boundary line, okay? Now, why do you think this boundary line is a dotted line and not a solid line? Sophia?
Because solid line is greater than, equal to, and that one's not equal to.
Excellent. This is not equal to. This is just less than. So it's going to be a dotted line, okay? Now, step number 2 is going to help us figure out which side of the graph we shade, okay? So we all know how to graph y equals 2x, right? We start at 0 and we go up 2 to the right 1, up 2 to the right 1. So that's why this line is here, okay? Now, step number 2 is test a point that is not on the boundary line to determine whether it's a solution of the inequality, okay? We are always going to test 0, 0, okay? Because 0 is easy to plug in for x, 0 is easy to plug in for y, okay? The only time you can't use 0, 0 is when your line goes through 0, 0. When your boundary line goes through there. Then you should pick a different point, okay? And then our third step is to, if it works for our equation, okay, then we're going to shade that region. So if 0, 0 works, we're going to shade the side that 0, 0 is on. If it doesn't work, guess what we're going to do? Shade the other side, okay? So it's much easier once we do an example, okay? So take a look. We're going to graph a linear inequality in one variable, okay? Step number 1 is to rewrite the inequality with an equal sign. So this is now going to be y equals 2, okay? Because y is less than or equal to 2, okay? So step number 1 is write y equals 2. Let's graph y equals 2. What kind of line is y equals 2? Sophia? Horizontal through what point? 2. So draw a horizontal line through 2. Now, we also have to factor in, should it be a dotted line or a solid line? Diego? Why?
Because it's less than or equal.
Excellent. So put a circle around that inequality and write solid. Okay? That indicates that we're going to have a solid line. So points on our boundary are going to be solutions. Okay? Because it's solid. If it was dotted, points on the boundary would not be solutions. Gabby, question. Did we do this in another lesson? We did?
No, that was with the dots, like the close and open dots.
Ah, this is very similar to closed and open dots.
Solid again?
Why is it solid? Because it's less than or equal to, okay? In the next example, do you see how it's y is greater than 1 or negative 1? It's going to be a dotted line, okay? So we've got y is less than or equal to 2. Step number 2, okay? Check if 0, 0 is okay to test. Does our line go through the point 0, 0? No. So it's good to test, okay? So we can test 0, 0. And then third step is plug it in, okay? If we plug in 0 for y, does that give us a true statement? Is 0 less than or equal to 2? Yeah. So if we prove that 0, 0 is a solution, we're going to shade the side of the graph that includes 0, 0. So shade the bottom. All of the bottom, okay? So you're going to shade literally everything on your graph that's below your line.
On the test, do we have to like
Yeah, you have to shade it.
the entire thing? So it's like
Yep.
black.
Well, you don't have to shade it too
So we
hard.
just do like this, like.
Yes. Yes.
Can you have also seen, since it says y is less than or equal to, you could have just like done whatever y values are less than 2?
Excellent. Okay, so Hannah brings up a good point. She says, since it's y is less than or equal to 2, right? What values of y are smaller than 2? All the values down here. Do you guys see that? Yeah. Okay, so she's like, you just shade below that line. Okay, she's absolutely right. All right, let's check out the next one. Y is greater than negative 1. Okay, step number 1. Oops, not a highlighter. Step number 1, rewrite it as y equals negative 1. What kind of line is that? Ah, it is going to be dotted. Who said that? Sophia, why? Excellent. So this is going to indicate it's a dotted line. But where does my line go, guys? Diego? Good. Negative 1 horizontally. All right. What am I missing on my graph? Marcio? Yep, the shaded portion, okay? So we have to shade either the top or the bottom. Do we know which side to shade right now? No. So we have to put a 2, put 0, 0. Can we use 0, 0? Yes, because it's not through our line. It's not on the boundary line. And then number 3 is test it. So plug in 0 for y. Is 0 bigger than negative 1? Yeah, so we shade the side that our point is on. Is our point above or below the line? Above, so shade above the line. You said above, right?
Yeah.
Wow, Andrew, everyone's calling you out. All right. Is this okay so far? Or no? Be honest, guys. This is the first time we're seeing this. Okay? It's all right? Okay, we're going to see one more with just x and a value. Okay? And then we're going to see where it's x and y in the same inequality. Okay?
Okay, so you put the dot there because of the 0, 0?
Yes. So I always test 0, 0 unless what? When do I not test 0, 0?
If it crosses
If what crosses?
the line.
If the line goes through 0, 0. Very good. But guys, You can test any point that you want. So any of these points will work or will not work? Will work. Any of these points will not work. Do you guys see that? So there's a reason that we're shading one side versus the other. Any point in here, and I encourage you to try it. Try 8, 0 or 0, 8. 0, 8. So x is 0, y is 8. Is 8 bigger than -1? Yeah, so it works, okay? But any point down here in this region is not going to work. That's why we don't shade it. Cool beans? Okay, let's check it out. Let's do example C. So x is less than or equal to -4. Sophia?
X equals -4, and then you put the line on -4 going vertical,
Dotted or solid?
solid,
Good.
and then you shade the left corner.
So this is solid. Excellent. Step number 2, can we use 0, 0? Okay, we can. And step number 3 is check whether it works. Is 0 less than or equal to -4? No. So 0, 0 is right here, right? Is it on the right or the left of our graph? So should we shade that side? No. We're going to shade the other side. We shaded the other side in this case because 0, 0 didn't work. Do you guys see that? See how I put an X next to when I plugged it in? So that means don't shade the side with 0, 0 on it. Got it? Okay?
Wait, what did you say? Don't shade.
So the reason we're testing this point, right, Jasmine? If it works, we want to shade it. It wants to be part of our solution. If it doesn't work, like this example, we don't shade it, so we shade the other side.
If it did work, we will shade.
Yup. Mm-hmm. Did we get it now? A little bit? Okay, let's try more harder ones. More harder. Yeah, there's a reason I teach math and not English. Okay, more harder is not a thing. Okay, so let's try the harder ones. Preston, what's up? Yes, okay. So we're going to graph the inequality in a coordinate plane. Okay, we've got -x plus 2y is greater than 2. First things first, same 3 steps. What do we do first?
Change the to an equal sign.
Change it to an equal sign. So -x plus 2y is equal to 2. And just like Andrew said, change it into slope intercept form. Hannah, what's up?
Do we still have that stupid rule if we divide by a negative, the thing flips?
Yes, but it's not stupid, okay? Now, Hannah, the reason that we're changing this to an equal sign is so that we can ignore this rule in these examples, okay? If you want to leave it with this and then check out if y is bigger than or less than, that's fine, but remember, always flip it if you divide by a negative, okay? I see what you're doing. Andrew, how do I change this to slope intercept form?
I got you.
Daniel, help me out.
Add x, and then we get 2y equals x plus 2.
Good.
Divide 2 to each side,
Mm-hmm.
and then we get
This is the tricky part.
1 over 2x.
No.
Oh yeah, plus 1.
Plus 1. Okay? Very good, Daniel. Why'd you get 1 over 2x?
Because there's a 1 for the x,
Correct.
so you get 1 over that.
There's a 1 here, okay? Now, it's very nice to write it like this because now what's our slope, peeps? 1 over 2. And what's our y-intercept? 1, okay? So let's go ahead and graph that. So we're going to start at 1. And how am I going to move? Sebastian?
Up 1 to the right 2.
Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Now, before we can draw a line, we need to know what kind of line it needs to be. Andrew?
Dotted,
Dotted. Why?
because it's not like greater than or equal to.
Excellent. Okay? So we need a dotted line going in this direction. And that's pretty terrible, but you guys can do better because Notability has a feature where you can draw it. I'm not in Notability, that's why mine kind of sucks. So just bear with me, okay? Now, second thing that we do. What's our second step, peeps? Sophia?
Put it like plug in
0, 0. Can we use 0, 0 here, peeps? Yes. Why can we use 0, 0?
because
Jasmine?
it's not crossing.
It's not, our line doesn't go through it. Very good. Okay, so we're going to use it. And step number 3 is actually plug it in. So plug in 0 for x, plug in 0 for y, and see if it works. We've got negative 0 plus 2 times 0 should be bigger than 2. Okay? This is going to be 0 plus 0, which is just 0. Is 0 bigger than 2, peeps? No.
Oh, that's a picture.
Okay? So, what do we do with that information? Andrew?
You shade everything above it.
You shade everything on the other side.
Or like
So,
that corner.
the point was below it, right? So now we're going to shade above it. Okay, now these are 3 new steps that we've never seen before, okay? So it should be a little tricky in the beginning, but do you guys see how this isn't so bad once we get the hang of it? Okay? All right, let's try another one. B, x plus y is less than or equal to negative 4, okay? Step number 1. Equal sign. X plus y equals negative 4. Step number, oh, nope, we're not done yet.
Slope intercept form.
Slope intercept form. How do I change this into slope intercept form? Kristen?
Subtract x from the side.
Good. What do you get?
So then it's y equals negative x minus 4.
Booyah. Y equals negative x minus 4. Excellent. Can we graph that?
Yeah.
Andrew, go for it.
You're gonna go to negative 4, and then you're gonna go down 1 over 1.
What does over mean?
Like rise over 1.
What does over mean, though?
To the right.
To the right one, okay? Down 1 to the right one. Down 1 to the right one, okay? What kind of line do I need? Solid. Why? Uh-huh. Thank you, German. So we're going to have a solid line like this. Oh, that's really my best work, guys. Appreciate me for like 2 seconds, okay? That's the straightest line I could do. All right. Thank you, Javonsky. All right. What do I do next? See if 0, 0 works, okay? So step number 2, 0, 0. Can we use it? Yeah, because it doesn't go through our line. And then step number 3 is test it out. So 0 plus 0 is less than or equal to negative 4. Is 0 less than or equal to negative 4?
No.
Oh, yeah. Oh, it's negative.
0 is technically bigger than negative 4, right? So if it doesn't work, what do I do?
Shade the other side.
Shade the other side. So shade underneath your region.
It's like it's easy, but it just has a couple steps.
It's easy, but it's a couple steps. Guys, it's very easy to forget one step and get completely confused, okay? So you have to know these 3 steps, what they mean, why we're doing them. What's up, Storm? This is the last one. We've got x minus 2y is less than 0, okay? Step number 1. Who knows it? Adrian.
Subtract x from both sides.
Good, but before we even do that,
Oh,
equal sign, okay? So we have to write the same equation with an equal sign to get our boundary line, okay? And then you said subtract x, right?
yeah.
Excellent. So we've got negative 2y equals negative x. Adrian, last step.
You gotta put, we divide 2 from
Not just 2. Negative 2. Very good, okay? So divide by negative 2, we're going to get y equals what? Sophia? 1 over 2x. German, graph that for me.
You start at 0 because there's no y intercept.
Mm-hmm.
And then you go up 1 to the right 2.
Up 1 to the right 2. Love it. Now, is this going to be a dotted or a solid line? Sebastian? Dotted. Very good. Why?
Because it's not equal to.
Excellent. So put a dotted line. What else do you guys notice about this graph that was different from all the other ones? Jasmine? It's not going to work because it's on our boundary, okay? So guess what, guys? You can pick any other point as long as that point is not on your boundary. So, Sebastian, give me any point on this graph that's not on the boundary line.
It's infinitely I can't. I mean,
You definitely can. Pick any point that's not on this line.
-5. -5, 3.
-5, 3. All right, we're testing that one out. -5, comma 3. Is it on our boundary line? No, so we can use it, okay? So plug in -5 for x, plug in 3 for y. So step number 3, -5 for x minus 2 times 3. This is less than 0. -5 stays the same. And then this is minus what, 6? Is that less than 0? It's going to be -11. Is -11 less than 0? Yes. So if that works, do you see how our dot was above our line? We shade above our line as well. Wow. Is it what?
Whatever point you choose, is it always gonna be
No, when it doesn't work, right, then you shade the other side. Okay? Now, trick question. Not a trick question, but like, I want to see how well you guys know this. If I picked a point on the boundary, would it work or would it not work? Why, Kristen?
Because
Or what you think it would work?
I think it wouldn't because it's past the line going through it. Or,
I get it.
You're right, it wouldn't work for this problem, but your explanation wasn't spot on. Diego?
So if there was like another question, and let's say a point on the line would work, we technically couldn't answer because we wouldn't have anywhere to shade.
Okay. So what if I told you that a line on the boundary would work here, but it wouldn't work here? What's the difference? Javonsky?
Because there's an equal to under the grading definition less than.
Excellent. So if it's dotted, okay, lines on the boundary are not going to work. Points on the boundary are not going to work. If it's solid, guess what? Points on the boundary are going to work, okay? So any point on this boundary line is a solution, okay? Any point on this boundary line is not a solution. Now, why do we test a point that's not on the boundary line? Because we already know what's going to happen on the boundary line, okay? We already know that the point isn't going to work, but we test the point outside so we know which side to shade, okay? Because if we tested on the boundary and it didn't work, would that tell us which side to shade? No, okay? That's why we test outside the boundary line. All right, guys, go ahead and jump to the bottom where it says this is Karen, okay? So pretend Karen was absent today and is demanding an explanation of the notes. Help Karen as best you can with 2 sentences summarizing the notes. That means no more than 2 sentences, no less than 2 sentences. Go.